as we see some interesting meteorological phenomenon happening, some severe storms over the U.S., and let's talk about what causes them. Here at the Smash News Network, we're interested in facts, which is why we're the least busted name in news. What causes these severe storms, folks? The severe storms in the U.S., the reason that Tornado Alley is around this area is because of cold air being infused from Canada. When the jet stream bends, it pulls cold air down from Canada, where it interacts with warm air being pulled up from equatorial regions, subtropical regions like the Gulf of Mexico. And what you get then is massive pressure gradients. That is what causes the severe weather, and a prime example of it here, you can clearly see, we're actually looking at temperatures here on nullschool.net. So here are the surface winds, and you can see the collision of these winds here. Southerly winds meeting northerly winds, a prime recipe for severe weather. Let's zoom out and look at the rest of the surface winds of the Western world. Powerful cyclonic system here in the North Atlantic once again. Here are the jet streams of the west. And you can see the jet stream dipping way down and making this meridional bend over the central U.S. That is the cause of the U.S.'s severe storms. Also some powerful rotations here in the southern hemisphere and some extreme bends in the jet stream down there as well. Here are the jet streams of the eastern world. There you go. And we'll close out this slide with the surface winds. There are the surface winds of the east. Some strong ones off the coast of Kamchatka as well. The northern Pacific and northern Atlantic both seeing cyclonic systems. Next, looking at lightningmaps.org. It's where I go for my real-time lightning maps. And give that a minute to refresh, as there are some active cells, I believe. And we are streaming live to Twitch right now, folks. Let me just press refresh, as it looks like it's not showing current data here. And just give it a minute. It's probably well worth it. We apologize for the delay. There we go. Hey, Kentucky. Hey, Louisville. You might be in the crosshairs. Hey, Bowling Green. Look at the active lightning. Absolutely shocking amounts of lightning there. Lots of thunder being created in Kentucky, mainly Kentucky, mostly north of the Kentucky-Tennessee border there. And here's the NASA GOES lightning mapper, and you can see how dense this lightning is. It's continuing on here. You can expect these systems to move into Indiana, Ohio, West Virginia, Pennsylvania, Virginia throughout the day today. Absolutely crazy amount of lightning there, as pressure gradients attempt to equalize the pressure of the atmosphere. Speaking of pressure, here's where pressure cells are now, and you can see this massive pressure gradient, this high pressure coming down like this, and then this low pressure being sandwiched in between this other high pressure right here. So there's a high, there's a powerful low. Here's a series of weak lows. And this is actually high pressure, relatively speaking, as well. And we'll zoom out to the global view. Here's the global view, and here is where the Euro forecast has pressure at 12 noon Eastern Daylight Time tomorrow. And we show that daily. It's a bit of a forecast. Continuing on with more meteorological stuff, check out the U.S. Doppler radar map. It is yowzers. Oklahoma, Arkansas, Missouri, Kentucky, some Tennessee there, the eastern part of the state. getting some very concentrated thunderstorms here as a result of massive pressure gradients and temperature gradients. That cold air being injected by the jet stream from Canada. Here's what's going on in the cloud layer, and this massive region of moisture is the sort of the location of the low, really a series of lows. And here's the water vapor map. That should give you insight into the movement of those systems. And let's actually zoom in. We're going to zoom in here on the Arkansas-Tennessee border. Just give me a minute to get those loaded. It should give you a very good insight into the behavior of these systems. It's going to move in a fairly predictable fashion here, it looks like, folks. So there's water vapor, and there is the cloud layer, 3.9 nanometers. It's all part of the NASA GOES Interactive Weather Satellite Suite. And we'll actually zoom in here on the radar as well. I would have preferred a different one. All right, let me just bring that up. Give me one moment, folks, to get this to load. There we go. That's going to be a better view. And keep in mind, folks, the most severe weather in the northern hemisphere occurs at the northwest corner of these systems. So if you see a severe thunderstorm headed your way, I highly recommend checking out lightningmaps.org. It'll show you where the lightning is striking, and that's where you definitely don't want to be outside. Lightning bad enough to even cancel bike races. One of the only things that cancels a bicycle race is a severe thunderstorm. And that's today's Cosmology segment. Bye-bye, Twitch.